All right, so we're wrapping up the rest of the lesson from Tuesday, talking about the definite integral, talking about how to find the area underneath the curve, applying the fundamental theorem of calculus, okay? Remember, integration is the reverse of differentiation. It allows us to find the area underneath a curve between two x values, okay? And so on Tuesday, you guys learned how to not just approximate it using trapezoids and rectangles like we did earlier, but you actually learned how to find the exact area. That was finding the antiderivative, that was plugging in your bounds and then subtracting the top bound from, or subtracting the lower bound from the top bound, okay? So the following diagram shows part of the graph of f of x equals 16 minus x squared times x plus 3. X is the element of all real numbers. The shaded region R is bounded by the x-axis, the y-axis, and the graph of f. You have to write down the integral for the area of region R. So in other words, you have to write what the integral would be if it were given to you, okay? So you know you need your integral symbol, the best one that you can do, okay? And then to represent the shaded region, you are going to need bounds. What's going to be your lower bound? 0, because that is the start of your shaded region. And then you need your upper bound, which would be the end of your shaded region. What value is that?
4.
It's 4. Now you can find this value either by solving the equation that's given to you. Okay, it's already in factor form, so you can set the factors equal to 0. You're looking for the positive value. Okay, or you can type into your calculator and find that x-intercept on your calculator. Either way, the answer would have been 4. Now, beside the integral symbol, you need the integrand, which is what? What goes beside the integral symbol?
The original equation.
The original equation. So that's your 16 minus x squared times x plus 3. And then every integral, every Riemann's integral is written. You always have to remember something at the end of this, which is what?
Dx.
The dx. Okay, anytime you write the integral yourself, that is your proper notation. The integral symbol goes with the dx, because remember that tells you your variable integration. What exactly are we integrating with respect to? So you need that. So this will be your answer for part A. Any questions?
No, ma'am.
Okay. So for part B, this is where you actually find the area of the region. In other words, you actually evaluate the integral, okay? Now to do this, what do you think I should do to the function?
Simplify, so FOIL.
Let's FOIL it out, okay? So when I FOIL, this gives me a 16x minus x to the third plus 48 minus 3x squared. Yes, of course, this is not in order, you know, from least to greatest, but essentially I'm just going to be taking the antiderivative of it. So I really don't, I mean, if you want to put it in order, you can, but, you know, I'm still going to take the antiderivative of it. What's the antiderivative of 16x?
8x squared.
8x squared, very good. What's the antiderivative of negative x to the third?
Negative 1/4 x to the 4.
What's the antiderivative of 48?
48x.
And then what's the antiderivative of negative 3x squared? Very good. So once I take the antiderivative, this is where we actually evaluate it from 0 to 4. That's when we apply the fundamental theorem of calculus. Remember, the fundamental theorem of calculus is you take your antiderivative, you plug in B, you plug in A, and you subtract the two from each other. Which one's B?
4.
And A?
0.
So I'm going to plug in 4 for all of my x's. It's a lot here. And then subtract it for when I plug in 0 for all of my x's. Now I'm just writing this out in this particular way, just so that everybody can see I'm applying the fundamental theorem of calculus and plugging in my bounds. But of course, that entire second parenthesis is going to be what? What value? 0. This whole thing equals 0, okay? So I just need to figure out what 8 to the 4th, 8 times 4 squared minus 1/4, 4 to the 4th, plus 48 times 4 minus 4 to the 3rd is. So I type that in my calculator, and that's how we find the area underneath the curve, the area of that shaded region R. What do you get?
I got 192,
192?
but I would check because maybe my friends do that way or something.
Can I get confirmation? I got 192. So then we're good. 192. That is what we did on Tuesday. That was part of what we did on Tuesday. We did a lot of finding the area underneath a curve, a lot of doing the integration of a lot of functions. Some with equations we didn't even know, we just knew the area, but we were still able to find the integral. We also did it using geometric shapes as well. Okay, so anytime your area forms a geometric shape, like a circle, a semicircle, a triangle, you can use old school geometry formulas to find the area underneath the curve. Okay, when you're given a function and it doesn't form a shape, then you use the fundamental theorem of calculus. And as you can see, we did that here. Now, not every function can be done by hand. Well, at least for you guys, you don't learn all the rules of integration to be able to find a lot of these things by hand, okay? You guys have the luxury of having the calculator for the entire exam. So for those functions, and for those functions that you can't do by hand, or even for the ones that you can do by hand, like this one, you want to use your calculator. So now I'm going to shift over to the notes so we can finish up the notes from the other day. You use your calculator by pressing these two buttons. You press your math button, and then you press your 9 button, okay? This is for integrals that we don't know how to do by hand, or even the ones we do know how to do by hand, like our do now, okay? When you type math 9, this right here will pop up if you have the updated version of your calculator, and it's literally the integral that you wrote. All you have to do is just plug in everything. You plug in your lower bound here, you plug in your upper bound here, you plug in the function. Of course, if the function has a different variable besides x, you want to use x. And then of course you finish it off with dx, because that's how you write the integral. You click enter and it gives you your answer. Now for some of you guys, see me, you won't have this feature. So this is the order in which you put it in. When you go to math 9, it's going to pop up FNINT. You type in your function, comma, you type x, comma, so that it knows it's doing it with respect to x. The upper bound number, comma, the lower bound number, and then close off parenthesis. Okay, so that's for those who do not have that feature. So we're going to do this. We're going to check this, our answer from the problem of the day, using this feature. So we go to math. Option 9, and for me, yes, the integral pops up. My lower bound was 4. I pressed the up arrow. Sorry, my lower bound was 0. I pressed the up arrow. My upper bound was 4. Now I'm going to type in my function. I am going to use the non-simplified, the non-foiled version, just in case, we made a mistake or something in our foiling. And I'm making mistakes pressing extra buttons. There we go.
So you put in like the original?
Mm-hmm. I would always put an original just in case you did like your foiling wrong. And then it was x plus 3. Yeah, it was x plus 3. Okay. And then I'm go over, and then I want to put a dx. It's exactly the integral that we wrote with an additional sets of parentheses. And then when we click enter, we do get the area underneath the curve.
Will we always put an x at the end?
Yes, you always make sure that you fill in that last space. Otherwise, you're going to get an error message.
So we have to write this in our book so we get a point, right? For math.
Well, yes, because essentially this is the integral that you are finding the area of. Okay, so again, these are for the functions that you know, you do know how to do by hand, like say if you want to check your answer. And then of course, for the ones that you don't know how to do by hand, such as like these two from our problem of the day yesterday or Tuesday. This one, we did it using the trapezoidal method. We approximated the area. Well, now we can use our calculator to get the exact area because you guys don't know how to do these types of problems by hand. So you're going to use your calculator. So again, what two buttons do I press? Math 9, and I fill everything in. If yours does not look like mine, you have to do the function, comma, x, comma, upper bound, comma, lower bound. All right, so square root, 4 minus x squared, no matter what, we'll always use x. Doesn't matter if the variable's in or something different. Make sure you close it off with the dx. And there we go. I believe that was the answer.
Yeah.
I think so. Okay, I think we did it was an approximation, but this would be our exact. What is 3.141593?
Is that hard?
That is pi. So if just in case it said what's the exact area, you know that it would be pi, okay? From our notes from 5.2, we also did this one again. Math 9, from 1 to 2. You can do this for any function. Even if you do know how to do it by hand, you can do this for any function. Just make sure that you write down the integral so that way you can at least get some method points and things like that. And I think that was our area from this particular problem back in the 5.7 notes. So now you know how to do it by hand and using the calculator. Do you guys have any questions? Okay, I want you guys to give this one a try on your own, okay? You have a function y equals negative x squared plus x plus 6 that's shown to you. And as you can see, the shaded area is underneath the curve from A to B. You have to write down the coordinates of A and B. Why do you think those are important?
Upper and lower bound.
They're your upper and your lower bound, so we definitely need those values, okay? And then I want you to find the shaded area. You can do it by hand if you like, but you do have the method of using your calculator, okay? So go ahead and do this one. So to find the coordinates of A and B, you are essentially finding your x-intercepts. Of course, you can do this graphically by plugging in 0 into y1 and the function into y2 to figure out where those intersections are, and that will give you your coordinates of A and B. But I'm definitely going to use this time to review how to factor, okay? Don't forget about factoring. Anytime the leading coefficient is a negative, factor that out. So then that way you won't have any issues when it comes down to factoring out your polynomial, okay? Or your trinomial. So now we ask ourselves, what two numbers?
-6 and 1.
What about -6 and what about 1? Multiply to give you -6 that add together give you 1. What two numbers multiply to give you -6, add together give you 1? 3 and -2. So then this essentially factors down to be x plus 3 and x minus 2. For any of you guys who are still in the process of taking like the SAT and the ACT, factoring is a big concept on those. So you need to make sure you haven't forgotten how to factor. Also, quadratics is one of our other sections. And so, yes, you are going to need to know how to factor. You said both of those factors equal to 0. You don't worry about that negative sign on the outside because it's just -1. -1 cannot equal 0. So you get x is equal to -3 and x is equal to 2. So A is -3, 0, and B is 2, 0.
I didn't get that.
Huh?
I didn't get that.
Did you do it using your calculator? Okay, so let's see what happened. Did you plug in? Did you do y1, 0? Okay.
I did y1 is the formula.
Okay. Did you plug anything into y2?
0.
Okay. And then we graph it. So then.
Miss, Miss Anderson, I think the reason we didn't get the same answer when we did on the calculator is because there was that negative on the outside. So don't you have to multiply it by the 3 and the -2, so then they would change, and then you do the equal 0, right? Like the slide divide bottoms up thing, like you have to.
If you did it that, yeah, we probably should have did slide divide bottoms up. Yeah, we should have did slide divide bottoms up. We'll clear on that. So when we slide, that means we're looking for two numbers that multiply to give us +6, that add together to give us 1 that's still in.
It's -6. I mean, +6.
When you slide, it will give you the positive.
But you wrote it as a negative.
Oh, thank you. So then it would be 3 and -2. And then you'll have to divide. So then it'd be x -3. Okay, there we go. And then x + 2. So when we set those both equal to 0, x is equal to 3 and x is equal to -2. So my mistake. So it should be B is 3, 0, the positive version, and A is -2, 0. So then we have our integral. It's going to be from what to what? -2 to 3 of our function, that -x² plus x plus 6. Don't forget about your dx. Make sure that you write it, even if you are going to be doing this using your calculator to find the integrals, to find the area, still write that down. So in that way you can get your method points. Because there are times when you don't get your full points because you did everything in your calculator. So you want to be careful of that. Math 9, we type it in. Don't forget about your x. Did you guys get this? You can convert it to a fraction if you like. Either one would be acceptable. Just make sure that if you do the decimal, you round to 3 significant figures. So your area is 125/6 or 20.8. Something else that you can do using your calculator, since I do have the function already in, if I go to second trace and option 7, you see that symbol in 7, the integral symbol? If you click 7, it says lower limit. Well, my lower limit was -2. Click enter. My upper limit was 3. Type that in, click enter, and it does it also for you in the graphing feature as well. So you go to second trace, option 7, because 7 is the one for the integral. That's the integral symbol. At the bottom, it says lower bound. So you type in whatever your lower bound is. So that's -2. Click.
Wait, how did you type it in?
Just -2.
Oh, you have to press the parentheses with the negative sign?
Yes, because if you press this button over here, you're pressing minus. You don't want to do that. You want to do -2. Then it'll say upper limit. So you type in your upper bound. So that's 3, enter. And then it does the area for you. It even shades it so it looks exactly like your picture. The same answer, just another way to get it. This one, we are given the function, and we're also given the area underneath the curve to be 6A units. We don't know what our bounds are. We're asked to find what they are. So we're going to do this one together. This one's a little bit more on like that harder level, but it's still incorporating the same things that we have been doing using integrals in the fundamental theorem of calculus. So I want to set up the integral that represents this shaded region. What's my lower bound? It's negative a. What's my upper bound of my shaded region? A. Got our lower bound and our upper bound. Beside the integral goes our function, x squared plus 2. And then don't forget about your dx. And remember, when I evaluate the integral from my lower bound to my upper bound, it's going to equal my area underneath the curve. So it's going to equal my area, which is 6a. Is everybody following on the setup?
Yes.
Okay. So in order to actually find the exact value of a, we are going to want to apply the fundamental theorem of calculus to the left-hand side, set it equal to a, and then continue to solve this problem. So I need to take the antiderivative of x squared plus 2. What is that?
1/3 x.
And I want to evaluate it from negative a to positive a using the fundamental theorem of calculus. Which bound do I plug in first? A. So this is going to be 1/3 a to the third plus 2a. Then I subtract it from when I plug in the bottom bound. That's going to be 1/3 negative a cubed plus 2 times negative a. All I did was plug in the upper and lower bound using the fundamental theorem of calculus to get that last or that bottom purple line. All of this equals the area bounded between those two x values. So all of this is equal to 6a. From here, we just need to solve for a, okay? Me personally, I am going to simplify that negative a cubed and that 2 times negative a. What's negative a cubed?
Positive a.
Careful, negative a times negative a times negative a, that'll be a negative a cubed. So this is going to be a negative 1/3 a cubed. And then 2 times negative a is a negative 2a. And this negative on the outside, I'm going to distribute. Now, of course, I'm more prone to do this by hand. So I always like to, work that skill of my brain. Combine like terms, a cubed and a cubed, I can combine those together. So it's 1/3 plus 1/3.
1/6.
2/3. You were thinking multiplying. Remember when you add, you just add your numerators. They already have like denominators. 2a plus 2a is?
4a.
So now you have a simplified down expression. If you want, at this point, you can plug it into your calculator. y1, y2, of course, using x instead of a, seeing where they intersect to find your values of a, or the exact value of a. Oh, no, sorry, it says exact value. We got to keep doing this by hand. Because if it's not a whole number.
I apologize for that.
So we can't use our calculator because if a ends up being a decimal, that's not going to give us our answer because we have to find the exact value of a. That is your non-rounded, most simplified answer. So we have to keep solving this. We have to keep solving this. So what do I do from here?
Can you divide by 8?
divide by A, okay? Could divide by A. I might lose a solution along the way if I do that. But that'll be A squared plus 4 is equal to 6. I do lose a solution, but it's not going to be the solution that I want. Because if it's a cubic, I should have 3.
Subtract the 4. That's what we should have did first.
Huh?
We could subtract the 4, can't we?
The 4A? Okay.
Yeah, that's what I would have did first.
Either way, we're still kind of in the same position. If I do that, I'll get 2A on this side. I like fractions, but I know y'all don't. So how do I get rid of this fraction?
Multiply by 3.
Multiply both sides by 3. So this turns into 2A cubed equals 6A.
Then divide by 2.
Three A. Sorry, I had a brain fart. I was like, what number is this?
And then find the cube root of both sides.
But I got an A over here on the right side.
Oh.
You end up losing solution when you divide. And if this, say something like this, something similar to this was on your SAT and was asking you to find your solutions, you're gonna end up getting it wrong because you lose the solution. Since you have a cubic and it's a regular variable on the same side, or in the problem, bring everything to the same side, and instead of dividing by A, factor out an A. Since both terms have an A in common, you can factor that out, and then you'll be able to set the outside equal to 0 and the inside equal to 0. This way you don't lose any of your solutions. So I already know one of them is A equals 0, but clearly that's not going to be the value of A. It has to be on either the left side or the right side. So it's going to come from this part. How do I solve for A in the second equation? Add 3. And then
square root.
And remember, whenever you take the square root, it's going to be
Plus or minus.
And this is the exact value of A. That's why we were not able to plug it into our calculator, because it would have given us the decimal version of the square root of 3. It's broken down into pieces to kind of help lead you to your actual area of your shaded region. In part A, it's asking you to find the area of the region bounded by the x-axis, x equals 0, x equals 3, and these two functions. So you're asked to find the area of the region bounded by the x-axis, x equals 0, x equals 3, and each of these functions. So in part AI, you're finding the area bounded by x equals 0, x equals 3, which is that point here, the x-axis, and the curve. So that's what you are finding the area of. Looks like a right triangle, correct? So if I wanted to, I could do, area of a triangle. But I am going to kind of harp on integrals here. What's my lower bound?
0.
And my upper bound? So I need my function dx. Type that in. Tell me what my answer is.
4.5.
Okay, real quick, if I were to do it using your fundamental theorem of calculus,
Will IB problems tell you specifically to do that? Like to write it out like that?
I mean, it could, if it's a show problem, you'll definitely have to know how to do it by hand. If it says exact, like how the last problem did, you'll definitely need to know how to do it by hand. But yes, 4.5, same thing, 9/2. So for a double I, I'm doing the same thing. I'm doing the integral bounded between x equals 0, x equals 3, the x-axis, and the curve. So what's my lower bound? Upper. And then I have my curve, my function. Don't forget about the dx. What you guys get for the area? 9. Good stuff. So then it says, hence, find the area of the shaded region. How do I do that?
You subtract 9 from
Exactly. To find B, to find this shaded area, I essentially need to take the large orange part and subtract it from that light yellow triangle area to find just that shaded region. So I'm going to basically take your answer from part A double I and subtract it from your answer from part AI to get the area of the shaded region. And what's 9 minus 4.5? Or 9/2. You wouldn't be able to do this one in your calculator because it always gives you the area between your x-axis and your curve. So if you tried to do it like, maybe just like as one thing, you wouldn't be able to do it. You would have to do the area underneath the line, the area underneath the curve, and then subtract them. That's the only way that you'll be able to find the area of like a section.
And it's always going to be above the x-axis, right?
If it's not, then that means the area is negative. Yeah. And that's how we round up. That's how we round off and finish up with integration. This is as far as that you guys will need to know. Of course, it goes way beyond this point, okay? Goes way beyond this point, but you guys have been introduced to this concept, being able to find area underneath a curve, being able to find functions, and be able to approximate area as well using the trapezoidal method. All these concepts are topics that you're going to need to know for your exam, if you have one. So when you have an integral with bounds, that's known as your definite integral. You don't need a plus C when it's a definite integral. But when it's an indefinite integral, indefinite means there are no bounds. It's just the integral symbol. Then that's when you'll need the plus C. That's when you'll use additional information to find the constant to get the original function. Okay, so definite is with bounds. Think of it like being defined. You're defining the area between two values. The indefinite integral means it's just a general function, okay, that goes on and on forever. That's without the bounds. This example from your 5-8 notes is going to help you with that one cognitive question that says f of 0 equals 6 and f of 2 equals 8, where you have to find the value of k, because anytime you have f of anything, that's letting you know that you have a point on your original function. One of those points is going to help you find your constant, like the 0, 3 helps us find our constant here. The other point is going to help you find that other variable, which is a in this particular problem.